We are identifying ions in an unknown solution by running standard small-scale tests on a white tile with clean droppers and recording every visible change clearly. To keep results valid, we avoid contamination, rinse droppers between reagents, and follow an order that preserves the sample, starting with gas-forming tests, then anion tests, and finally, cation tests on the remaining solution. First, we run a flame test for metal ions using a clean nichrome wire dipped in the sample and placed in a hot blue flame, and we look for lithium red, sodium yellow, potassium lilac, calcium orange red, and copper blue-green. Next, we check for carbonate by adding dilute acid, and if effervescence occurs, we pass the gas into lime water, which turns milky because carbon dioxide forms calcium carbonate. We then test for sulfate by acidifying a fresh portion with dilute hydrochloric acid and adding barium chloride, and a dense white precipitate of barium sulfate shows sulfate ions are present. For halide ions, we acidify with dilute nitric acid and add silver nitrate, and we expect chloride to give a white silver chloride precipitate, bromide to give a cream silver bromide precipitate, and iodide to give a yellow silver iodide precipitate, with the further check that white dissolves in dilute ammonia, cream dissolves in concentrated ammonia, and yellow is insoluble. For some metal cations, we add a few drops of sodium hydroxide and observe hydroxide precipitates where copper 2 forms a blue precipitate, iron 2 forms a green precipitate, and iron 3 forms a brown precipitate, while aluminium, calcium, and magnesium give white precipitates with aluminium dissolving in excess. We test for ammonium by warming the sample gently with sodium hydroxide, and ammonia gas is released, which turns damp red litmus paper blue and has a strong, sharp smell. Gas confirmation tests help our decisions because hydrogen makes a squeaky pop with a lighted splint. Oxygen relights a glowing splint. Chlorine bleaches damp litmus, and carbon dioxide turns lime water cloudy. A flowchart of the method now summarizes the logic by starting with carbonate, then sulfate, then halide tests, and finally cation tests using either flame colors or hydroxide precipitates. Throughout, we note observations such as color of precipitate, solubility in excess, and behavior with ammonia, because these details distinguish close pairs like chloride and bromide, or aluminum and magnesium. Safety rules are followed at all times, including goggles, small quantities only, careful use of acids and ammonia, working in a fume cupboard for chlorine tests, and immediate rinsing of spills. Finally, we conclude by writing balanced ionic equations for each positive result, and we identify the unknown by matching the full pattern of evidence rather than relying on a single test.